Good morning, mathematicians. We're back. Oh, did I click the button that makes it remember these settings? Oh, and did I put the right picture? I think I did. It's that pre-coffee brain working in its pre-coffee ways. Wow, part one of Spectral Sequences has more views than my pre-recorded video on group cohomology. That always happens every time I start a new live stream series, though. I think the algorithm gives new videos a boost. Part one of Spectral Sequences. So that's not surprising. Yeah, let's get back to it. We're looking at some real spectral sequence stuff today. Still in the introductory chapter. But, you know, we've seen some graded vector spaces. Okay, so let's dive in. Hello, Arad. Good morning. Welcome back. Buenos dias. Buenos mañana. ¿Mañana? Sí. ¿No? ¿Cómo estás? Okay. Where were we here? I think we were right down over here. We now complete the preliminary definitions. So we were saying that once we take R big enough, hello, you're just looking at my answer to the question. Okay, good. Yeah, I was wondering. I was like, oh, you just posted that. I wonder, maybe you'll be here in the live stream as well. Sorry. Yeah. So as long as we take R big enough, everything eventually becomes the same. So a spectral sequence of vector spaces is said to converge to a graded vector space. Let's maybe... No, go get out of here, AI assistant. Hide for the session, yes. Write down some things. Why is my life so difficult right now? Really? It won't let me shrink anymore? Come on. Come on. So a spectral sequence of vector spaces is said to converge to a graded vector space. Converges to a graded vector space H if H has a filtration, which I guess such that, I mean, eventually this happens? Or this happens at every stage? I'm confused. We were also calling this... Wait, what? E naught PQ of H star. Huh. Oh, if there is a filtration such that this happens. Okay. Okay, I see. So this spectral sequence converges if we can cook up a graded vector space with a filtration that makes this true. Okay. Okay. And then I guess we're going to do work to build the graded vector space that makes this happen. Ooh. No, I didn't mean to do that. Oh, bother. Oh, bother, I've gone and botched it up again. Get ready for Halloween. That's a weird... Why are you telling me get ready for Halloween on the 19th, Google? Did you not have anything else interesting to say in the search bar? The existence here, if there exists a filtration, is a little annoying. The filtration is really a part of the data. The data of the graded vector space, right? But it's standard to leave it implicit. Am I making fun of your accent? I maybe was a little bit. I maybe was a little bit. Yeah. So you should chastise me for that. Yeah. Unfortunately, you don't have voice chat enabled. Otherwise, I'd invite you to make fun of the Canadian accent. You mean the data of the spectral sequence? Oh. But how could the data of the spectral sequence... or are you saying there's a vector space and the filtration, the spectral sequence induces the filtration on the graded vector space? Or what? I mean, I guess the graded vector space is also going to come out of the spectral sequence somehow. Well, when we do the cycle, co-boundary thing, right? Not much to say about it, eh? Oh, yeah. Let's go over to Tim's, bro, eh? Let's talk about it. A boat. Yeah. I mean, we have a diverse set of accents to make fun of too. You know, there's like the hardcore Newfie, which I feel like is where a boot really comes from. And then there's like the Quebecer. The Quebecer. When people say the spectral sequence converges to the cohomology of X, it should be with a particular filtration, which is obvious from context. Okay. Some may say, and I would attack these people with furious anger. Some may say canonical. This is bad form. This does not spark joy. Though the notion of convergence requires conditions on the filtration in order to determine the target is uniquely H star, this definition will serve for this first exposure. See Chapter 3 for more sophisticated issues. Oh, we'll get there. Maybe. It follows that our basic goal, H star, is approximated if we can find a spectral sequence converging to it. The general theorem in this enterprise takes the following form. Theorem 1. There is a spectral sequence... There is a spectral sequence whose E2 page converges to E star. Interesting. Okay. You have a professor that avoids canonical by saying preferred. That is good, except, I mean, really there is two uses of canonical at play here, right? And that's part of the issue. Because sometimes it means preferred. But sometimes it means not just preferred, but also that it is like functorial in some nature. And so, yeah, I try to either just say preferred or functorial. Yeah, or standard. I use the word standard choice as well. I use that sometimes. Preferred is good. Yeah. The important observation to make about this is that it gives an E2 term of the spectral sequence but says nothing about successive differentials. although the later pages may be known without DR or some further structure, it may be impossible to proceed. Okay. There is hope, however, that even without knowledge of the differentials, we can proceed as a formal consequence of the algebraic structure of some ER term. Analogous situation arises in a long exact sequence where every third term is 0. Right. Okay. Let's see this example. Whoa. Okay, we've got to think about this for a second. Hello, Kastakakori. Hello. Suppose there is a first quadrant spectral sequence of cohomological type with initial term E2? What? Why wouldn't we just call that one E0? I'm so confused. Good morning, Femnal. Or afternoon. Okay, but we're supposing that this converges to our graded vector space, E star. And we're supposing that the kth, for any piece of the filtration added onto the pth piece, it's 0. Then H naught is E2, 0, 0. And there is an exact sequence with this a submodule of H2. Okay. Okay, doke. Let's write down some of the hypotheses, I guess. So what do we got here? So let's say example 1A. And so we've got our spectral sequence going to H and Fp plus K of HP is 0. Then H0 is E2, 0, 0. And, okay, we'll write down this exact sequence later in the proof. Random question. Are there any cool connections between algebraic/arithmetic geometry and functional analysis? Considering to learn functional analysis, but you're horrible at analysis, so it would be hard work. Yes, as Arad says, the origins of scheme theory were at least inspired by functional analysis, if not directly related. Yeah, I mean, arithmetic geometry certainly... I mean, the Langlands program is basically all about, like, you're studying... It's a connection between automorphic representations, which are sub-representations of some L2 space of functions on a group, and relating those to Galois representations. So, yeah, it's got functional analysis all over it. There's definitely... I'm more in the algebraic geometry arithmetic side, but like there's a lot of functional analysis in the Langlands program, and you could definitely approach things from that. It was humbling to know Neukirch also talks about filtrations, but with profinite groups. You naively wonder why this is not enough technology to deal with Gal Q bar Q, but that's way ahead of me. Yeah. I gotta get a less squeaky chair. I've listened back to some of my videos. That squeaking is just awful. Yeah, I don't know what to do about that. If you get into complex algebraic geometry in particular, you'll encounter a lot of concrete function analysis, you know. Can you be really annoying and ask me to spell out the statement just before definition 1.1? Just before definition 1.1. Where's definition 1.1? I guess I could control F. First definition, I see. Oh, this is what you were asking about before, right? So the complementary degree in the index P filtration, the associated vector space can be recovered by taking the direct sum of spaces over the index Q. I think I mean, we sort of discussed this in the video yesterday, right? No, I guess I didn't write it out. But I think it is exactly this idea of like, I'm not actually sure. I'm not actually sure, to be honest. So like I said in the comment, I think what he means by recover the vector space, I mean, like, no way in hell this is literally or like literally equal to the original vector space, right? All there is for vector space is vector space isomorphism, and this is just dimension count. So, yeah, I think it's just a matter of going back and unpacking this definition and this thing and doing a dimension count and seeing that this is the dimension. You can't even see that they have the same dimension. Let's okay. Well, yeah, let's do it later in the stream. Let's do it later. I want to prove this. I want to prove this theorem first, and then maybe we'll come back to it. Yeah, I guess the tricky part of computing the dimension is computing this intersection. Start from thinking about just V mod W plus W compared to V. Yeah. 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 Like with yesterday when we talked about Z mod 4 sitting in the short exact sequence with Z mod 2 on either end, right? Basically, if you go through that, you recover the sum of the two Z mod 2s. It's not isomorphic to Z mod 4, but it's like has the same composition factors. That's roughly the idea, but yeah, it's different than us explaining it to actually going through it in detail. Okay, let's dive in. My arm's getting a little sore. Gonna kill my back by sitting weirdly instead. I think I should buy a lapel mic. I should buy two for the next time I have an interview guest. And then if I just have a lapel mic on every morning, it should be fine. I think I need to look into that. There's a lot of things I need to look into to improve this channel. Eventually, someday I'll do it. Maybe sooner than later. I still want a hat. It's not hat season, but I still want a hat that has QP on it. Okay. So since there's a filtration whose associated graded vector space is given by the... Oh, sorry, my writing pad. I was gonna... yeah. I have a Wacom tablet. This is what I use. Yep, that's great. How do I get Wacom to sponsor me? Someone yesterday commented on one of my videos asking about what I use. And I know normally companies reach out to YouTubers, but I wonder, like, can I don't know if my channel is big enough yet, but maybe when I cross 10,000 subs, can I reach out to Wacom? Because, like, I don't really care about, like, it'd be weird to, like, get sponsored by, like, Raid Shadow Legends or something. But, like, and I don't know, like, Brilliant would probably give me a bunch of money, but I don't know if I actually believe in Brilliant. I think I agree with Honest Taurus's critique of it. And so, but I do want money. And I would prefer to support companies that like whose product I actually believe in. So like, would it be that crazy for me to reach out to like the head of marketing of Wacom and be like, "Hey, this is a really unconventional buyer. I'm an unconventional buyer of your product, possibly, but not so much, right? They probably think, oh, we're mostly making it for digital artists, but a lot of mathematicians use these tablets. Anywho, getting ahead of myself here. I ain't that big yet, but I will be. I will be. Unless there's a cap on the amount of people that want to watch videos about spectral sequences in the world. Ooh, a sponsorship from Springer. Ooh. Yeah, maybe honestly, maybe once I cross 10K, I will reach out. To things that I actually care about and just be like, look, give me a little something. I'll talk about your stuff because I like it already anyways. Maybe book discounts on courses. I could like host a course and they could like discount the hard copy of the book or something. That could be cool. Okay, let's get back to math. Instead of fantasizing about my channel, weird. Since there is a filtration on here whose associated vector space, whose associated graded vector space is given by the E infinity term of the spectral sequence, then we can relate the final term to its target in the cases of H1, H0, H1, and H2. Right. So part of our assumption... right. And what did it mean to converge? To converge, it meant exactly this. Right. So the E infinity term could be represented by these quotients. Okay. So... why is F0 of H0 H0? That's just always true by definition. Yeah, we always take the 0th piece of the filtration to be the whole thing. Okay. And then F1 has a higher index than H0, so that is 0. Okay. Right. So then by this down here... E infinity 00 is just H0. Okay, sweet. No non-zero differentials can involve H200. What does that mean? What does it mean for a non-zero differential to involve H200? Springer holiday sale coming up. Lots of hardcover GTM books for like $20. I'm going to go broke. Because I'm just going to be like, oh, they're all $20. And then I'll spend all my rent money. Yeah, exactly. I always buy like 20 bucks. I gotta think about the fact that, I'll probably be moving in less than a year or two. I gotta cool it. I gotta stash these books somewhere like a squirrel burying their nuts for the winter. Every object has an incoming and outgoing differential. I see. So that's what it means to involve a differential. Rising Sea coming out in 2 days. Oh, yeah, I should buy that, but... eventually. So they're saying that's all zeros in all pages. No non-zero differentials can involve E200. Why though? I mean, it's a first quadrant spectral sequence. So if it had anything, it would be outgoing. But it's a lot easier to see if you draw it on the PQ plane. Yeah, let's see. Time to draw some pictures here. So here's 1, 1, 1, 2, 2, 2, dot, dot, dot. Let's make one more row of dots. So the E2 page differential. So let's see. The differentials to start off with are all horizontal, right? So the E1 page is like this, and the E2 page is like this, right? So if you look at the coordinate 0, 0, the arrows will go from the second coordinate to the fourth. Where's our definitions here? Right, E2, 0, 0 goes to E2. So it's plus R and then minus R plus 1. So it's plus R minus R plus 1. So we should be going from E2, 0, 0 should go to E2, E2 minus 1. I mean, maybe I think I index things differently. I'm thinking X and Y coordinates, and I think he swapped it around, but it should be something like this. Right, I see. But the negative degrees, I see. The negative degrees, I see. I see. And then the thing coming from it, I see. Right. And since we're in a first quadrant thing, it's all 0. Okay. I'm back on track here. Are you guys with me? My differential equations prof always used to say. Hello, Leo Lectures. I am doing well. How are you doing? You never emailed me to set up Lee Theory chat online. Then we can relate. Yeah. So where are we? Okay. I see. So wait, why is E2, 0, 0 equal to E infinity 0, 0? This makes sense to me, like on an intuitive level, because it's supposed to like collapse, right? So if all the differentials are already 0, quote unquote, turning the crank shouldn't do anything, but can we see that more precisely? Oh, I guess right, because the same thing holds. No, I'm confused. E naught PQ. You ended up being busy, so you didn't know when you'd be available. Yeah, fair enough. Wednesday, Thursday this week might work. Am I going over proofs that spectral sequences are valid? Well, not that they're valid. I'm teaching myself spectral sequences from a textbook here. Yes, they are supposed to compute filtrations of cohomology. Okay, I'm still trying to. So I believe you, Rod, but now I'm trying to see like why is H300 the same? Like this means that H3 00 used to use this in superstring theory. I don't even know what superstring theory is. But that's interesting. You should make a Halloween video out of this. Maybe spooky spectral sequences. I mean, it's a whole Halloween month of videos, basically, right? Spooky Halloween sequences. So like, okay, let's go E003. This is what? This is F0 H0 mod. Oh, I see. F1 H0. Right, which is F0 H0, which is H0. I see. Yeah, we've just seen E00 is always sandwiched. Wait, what do you mean? E00 is always sandwiched between two zeros? What do you mean by that? So when you take cohomology, it's the same object. What do you mean E00 is sandwiched between two zeros? You mean this? What I just wrote? Oh, right. Sorry, you're right. Oh, sorry. You're right. No, I understand exactly what you mean now. Right. From this picture. From this picture, we have a sandwich between these two zeros. But is it exact? Is this supposed to be... I mean, I guess it's a complex. It's a complex, but does this have to be exact? Yo, Pajama Man. I mean, I think the point is that this doesn't have to be exact, right? So... Oh, but, right, we have this statement that... right, EP, right, EP R plus 1 is the quotient of these, right? Let me write that down so that maybe it will stick in my head. EPR plus 1 is the kernel of DR and the image of DR. Yeah. Okay. You believe the spectral sequence prayer is basically like a long exact sequence and calling it a day. Well, I'm not satisfied with that. Hence this whole reading project. Halloween topic should be the Boone-Higman conjecture. I guess I should look that up. Maybe. Yeah, do I dress up and do a Halloween live stream? I have an idea for a Valentine's Day live stream because there's all these like, sexy math terms: kissing numbers, kissing fractions, marriage problem, sexy primes. There's something called sexy primes. I don't know what to do for Halloween though. Just more spectral sequences. It's exact if it's a first quadrant spectral sequence. Really? The first quadrant's always exact? Why is that true? Hello, McGreevy. I have no idea what the Rydberg combination principle is. Spectral sequences are a tool in advanced homological algebra. That's what they are. Do I have an example of a spectral sequence calculation that I'm using as context? No, but we should have one soon, I think. I mean, this is kind of an example. BH conjecture finite group has solvable word problem if and only if it embeds into a FP simple group, finite something simple group. McCleary starts with 4 chapters of abstract nonsense. Yeah. This is kind of an example, right? It's we're supposing it satisfies this specific thing. Right? It says example. Okay. No non-zero differentials can involve E2. Okay, so we have understood that. For H1 and H2, the filtrations may be presented as such. This leads to short exact sequences. Okay. Yes. I'm willing to just believe this by going back and unpacking our definitions, right? This is the infinity page, but okay, let's just work through it. The Rydberg combination principle is the basis for matrix mechanics. It's convolutional matrix arithmetic that defines the hydrogen energy levels. What? Convolutional matrix arithmetic? It links spectral theory to matrix multiplication. Foundation of reality. Well, that might be a dubious claim, but I mean, it sounds interesting. Okay. So let's just work through these. We're not shying away from the details here. So we have 0, F1, H1, F0, H1 being H1. And this should lead to these short exact sequences. So, right. FP. So let's see. E210 is supposed to be F1 H1 mod F2 H1, right? Yeah. Oh yeah, spectral here in terms of spectral sequences means a very different thing than spectral theory and matrix mechanics. Didn't mean to say it's the foundation of reality, meant to say it's the foundation of spectral theory. Right. Yeah, the term spectra or spectral here is being used in a different way. This is not synonymous with like spectral theory of operators. It's just a totally different usage of the term. Right. So F1 H1 right includes that's so this is just F1 of H1. This is just F1 of H1. Right. And then E201 is F0 H1 mod F1 H1, which is H1 mod this. Yes. Okay. So this first short exact sequence he's writing here is literally just F1, H1, H1, F, H1 mod F1, H1. And then having just unpacked the definitions, we get exactly these equalities here. Nice. We all know the foundation of reality is infinity topos theory. The idea is that the foundation of F1 geometry, that spectral theory, all essentially comes from the same thing? I mean, in what sense are you saying spectral theory here? Like, what does that have to do with F1 geometry? The ideas of foundation of F1 geometry. Not sure what you're saying there. So yeah, I'm vaguely aware that there's a highly speculative idea that if we found the right theory of F1 geometry, it could be leveraged to prove the Riemann hypothesis. But again, the conspectral triple, I think that might be yet another usage of the word spectral that's not necessarily related to spectral theory of operators nor spectral sequences. So the E infinity page, F1 geometry. Give me 1 second. I'll tell you about that in a second. So the E infinity page. Oh wait, I was computing the wrong thing. This is E infinity. Ah, damn it. I computed both of these as E infinity. But that was wrong. Darn it. Okay, that calculation. Okay, but that calculation will work here. Okay. Sorry. So the second sequence actually makes sense. The first sequence I did wrong though. I used the wrong formula. So hang on. E102. Well, this should be the kernel of E of D1 mod the image of D1. The conspectral triple is claiming that the Riemann hypothesis is a spectrum of a self-adjoint operator. What do you mean by that? How can a hypothesis be a spectrum of a self-adjoint operator? But, I mean, I guess, yeah. But actually, now that you say that, yeah, maybe there is a relation there, because I know there is some matrix approach to, I know that there is some matrix approach to the Riemann hypothesis. So maybe that's just a typo. And D1 is supposed to go from... the critical strip zeros relate to spectrum of self-adjoint operator. I see. Okay. No, that's right. I think you're right. Actually. I see. Are we calculating spectral sequence for CX from the last video? No, we're not doing that at all. We are not doing that at all. But what is the... Well, okay, DR went, right, DR went from ERPQ to here. So this should be the kernel of E1 0 minus r plus 1 e1 0 0 to e1 1 0. Is that correct? Right? dr goes from ERPQ to ER P plus R Q minus R plus 1, right? Yes. Right? Yeah. Attia said something similar in the last years of his life when he lost his mind a little. Yeah, but I do think there is a legitimate approach to this using saying something about relating the zeros to a self-adjoint operator. Right. P plus R. So this is true. Kernel mod the image. If you said the BSD conjecture relates to the rank nullity theorem, does that make sense at all? Not really. I mean, in the sense that the rank nullity theorem is just the most elementary fact about linear algebra, so it kind of relates to most of mathematics. But that that's like saying oh, the derivative relates to the Riemann hypothesis. Sure. Yeah. He conjectured that the hidden Hamiltonian for the whole universe's eigenvalues encode zeros to the zeta function. Yeah, I mean, that's just nonsense. And so now we're modding out the kernel. Wait. Kernel D1, shouldn't that be the image of D0? Now I have to go all the way back. I gotta find this definition. Wait, dr minus... Wait. Where are these both called dr? Oh, gosh. Okay, so this should be from... Right, the image of the appropriate dr. Right, so I need to subtract an r. So this is e minus 1, and I need to add, well, nothing in this case, e1. Wait. Sorry, p is 1. Oh my god. So E1 0. Oh, but this is R plus 1. Okay, so R should be 1, P is 1, Q is 0. The stream is going on so long today because I've become obsessed with solving this very basic thing. One day someone will learn that more indices may not always be a bad idea, to be more explicit. I don't know. To be honest, looking at the Hodge book example, it seems like a good way to learn chief cohomology too. That may be. Okay, so this should be... So P is 1, so this will be E... Okay, these indices are the same. So this is E1, 0. This will be 1 plus 1 is 2, 2, 0. And then this will be E1, 1, 0. And this will be 0, 0. The critical strip when M goes to 0 has an anomalous dispersion pattern. So you think the spectrum of the zeta zeros relating to a self-adjoint operator is not all that different from hydrogen spectra? What? What about that is similar? I don't... Anomalous dispersion of hydrogen spectra catalyzed the transition from old quantum theory to QM? What? What do you mean QM? What do you mean by QM? Old quantum theory to QM? What? Okay, anyways. Yeah, I'm starting to think that McGreevy might be have no idea what they're talking about as well. No offense, McGreevy, but it does kind of sound like... Well, then what do you mean? What do you mean transition from old quantum theory to quantum mechanics? What do you mean? What's the difference between those? I mean, I could be wrong. Maybe you know what you're talking about. But it right now what you're saying sounds a little bit like nonsense. You might not. Okay, well, then probably not. Let's see. Okay, we computed some of these terms. Right? We knew something about E100. We knew something about E100, didn't we? Didn't we say something about E100? Yeah, I mean, trying to draw something about, rank nullity and BSD makes me think you probably don't know what you're talking about. Because if you knew enough to understand something about how, to actually understand something about how the zeros of the Riemann zeta function are related to eigenvalues of a self-adjoint operator, you would also know that asking about the relation between BSD and rank nullity is nonsense. It's not new phenomenon that mathematical physics sounds to mathematicians like nonsense. Fair enough. Anomalous dispersion of hydrogen atom represents the excitation of electron to a higher state. Okay. Anomalous dispersion is precisely the absorption spectra of hydrogen. Okay. Don't hack me, bro. What is TS? I don't know. What is TS? What do you mean by TS? Okay, I just want to finish this problem and leave. We've been streaming for like over an hour. This is the longest live stream in months. This is a Sunday. Don't expect this. Don't expect this length tomorrow. Am I crazy? Okay, so we didn't compute any of the E1 pages. So how are we making these claims? Oh, wait a second. No, I don't understand what we're doing. Yeah, I don't understand what's going on here. Well, okay, hang on a second. Can we say that E102 injects into H1? Because H1, what do we know about H1? We did say something about H1. We did say something about H1. You do recall reading that terminology for spectra and function analysis comes from spectra of atoms and stuff. Oh, but you don't know how it works exactly. Interesting. Well, I mean, at a basic level, right? What's the spectrum of a matrix? It's the eigenvalues. And the point is that your quantum observables should correspond to eigenvalues of some, self-adjoint operator. And what can you actually observe about a hydrogen atom? Well, the states that you can observe, those are eigenvectors, and the actual energy values are given by the eigenvalues of the operator. So that would be the connection there. Yeah, I mean, I get what you're saying about hydrogen absorption spectra, but I don't know what you mean by transition from old quantum model to actual quantum mechanics. I don't know what you mean by that exactly. Now non-zero differentials can be H120. Yeah, what do we know about H1? Well, I hate to leave stream unfinished here, but might have to. I mean, H1 H1 is what do we know about H1? Yeah. H1. Yeah, I don't know. This is now I'm lost. What else can we say here? I mean, okay, if we know that E200 is E00 infinity, and we know something about this, H1 is obviously first cohomology. Yeah. And this is whatever, a quotient. This is just, yeah. So E200 is F0, H0, F1, H0. How does that help us at all? Well, I'm glad you're excited for that sawdust creator. Whoa, I didn't mean to do that. I didn't mean to do that again. Okay, maybe I should just end stream now. We'll have to come back and solve this tomorrow. Maybe I'll have a think on this in between. Is this like Hamilton came up with quaternions? I'm not sure I understand the question, Matthew Mathica. But we'll have to address it tomorrow. So I think we're going to end the stream on this anticlimactic thing. Yeah, I'll have to have a little think. Oh, F1 geometry, right? Okay, so hang on. I will just quickly explain F1 geometry. So the basic idea is this. Okay, there is no field with one element, right? No such thing exists. However, there does appear to be structures that want to behave as if there's a field with one element. For example, so the we have like the Weyl group of some algebraic group, right, over FQ. This is just like Sn. And so you can still make sense of this. Like there's some sense in which you should think of like GLN of Fn actually as being the symmetric group. You can still give a combinatorial representation. There's some document, if you Google like projective spaces over F1, there's like a simple thing where you can, the Q Gaussian polynomials, or Q Gaussian coefficients, sort of, these count the subspaces of an FQ, of an n-dimensional FQ vector space. But it turns out that these formulas still make sense if you set Q equal to 1. Even though there is no FQ, there is no field with one element. And so the question is, well, then, like, why does this still make sense? And there's some sort of idea also roughly that, like, from the perspective of étale cohomology, spec Z behaves in an analogous way to the way that, like, the étale cohomology satisfies some theorem that looks a lot like a theorem that you see for compact 3 manifolds. And that's kind of weird because spec Z is your terminal object in the category, and you would like that your terminal object in your category be a one-dimensional thing. So there's some idea is that somehow, like, a field with one element, okay, the field with one element doesn't exist, but maybe there's some broader category than the category of schemes in which there's yet an object that lives beneath this thing, and you should think of it as being like a scheme over the field with one element. And the idea is that basically, if we came up with the right category, then maybe the proof of the Weil conjectures could be leveraged to the Riemann zeta function. But it's a field with one element, though, so 0 equals 1. Well, it's okay. There's more to it than that. But anyways, okay.